7:30, so we'll get started. I'd like to welcome everybody and acknowledge that we are on Treaty 6 land, which is the traditional land of First Nations and Métis people. Just have to admit a few people here. We'll start. I can tell you, maybe I could, since I didn't put it in the notice to the members, I'll tell you what our bank balances are just to start with, and then we'll get to the minutes with Sukrit. Our general account is currently at $57,269.74. And our casino account is at $37,340.93. Is Luca with us?
Yes, I am.
So Luca, how is the participation for the upcoming casino? How's it coming along?
It's quite high. It's quite high. We still need a couple of people to run chips and a couple of people to count money. So there'll be another blast later this week, and hopefully we can complete the roster.
Yeah, this, and Luca, you can correct me if I'm wrong, but this casino might be the last we're having for a while.
Correct. We may not get another casino within the usual 2-year period because of the COVID backlog of charities whose casinos were canceled but have still yet to be reinstated. So the wait time to the next casino could be up to 3 years.
Right. And so everybody should, if you haven't volunteered for this casino, please volunteer. Give us a hand. Obviously, the center relies on casino funds for a major portion of its revenues. If we don't have that, then we may have to turn to other forms of revenue raising. I mean, if we have to do that, if we have to go there, we will have to go there. But if I would rather not have to rely on members for donations, for example. If we can get casino funds, that's great. But that could be on the horizon, depending on what happens with the casino situation. So, as I say, we really would appreciate you filling up those remaining spots in the casino that we do have. Okay, so if we can move on to the minutes, Sukrit, over to you.
Hello. Thank you. The minutes have been posted to the OneDrive. I posted it right after our meeting last month on February 14th. Are there any errors and omissions that I need to be aware of? I take that as a no. Okay. In which case I make a motion to accept the minutes of the meeting for February 14th, 2022.
Okay, do we have a seconder?
Bob
Lawrence, thank
Yeah.
you. Any further discussion? All in favor, you can signify it by yelling aye.
Aye.
Aye. Aye.
Any opposed? All right, carried.
Thank you.
Okay, now, thank you, Sukrit. Jeff, I'm looking for you again. I always look for you. Where are you?
I'm waving my hands.
Oh, there you are. Okay, I'm going to make you a co-host, and we look
Okay.
forward to your presentation.
Okay, thank you very much. Well, welcome to News from Space. This is a significant day. It's not only Pi Day, but it is also a 1-year anniversary since I first started doing this. So I will share my screen here.
Parker Solar Probe made its 11th close flyby of the Sun on February 25th during its quest to better understand how our star works. The plucky spacecraft dipped within 8.5 million kilometers of the solar surface. That's about 14 times closer than the orbit of Mercury. At closest approach, the spacecraft was moving at 586,860 kilometers per hour. By the end of its mission, the spacecraft will get to within 6.16 million kilometers of the Sun's surface. Getting that close to the Sun will allow scientists to continue making observations about the solar environment, particularly the corona. The Parker Solar Probe was launched in August 2018 to study the Sun's outer atmosphere. In between its main mission, the Parker Solar Probe has made a contribution to the study of Venus. New images captured during a close flyby of Venus show the planet in visible light for the very first time. The wide-field imager for the spacecraft imaged the entire night side of the planet in visible light, as well as in infrared light, revealing regions, including continents, plains, and plateaus on the planet. Additionally, scientists spotted oxygen in Venus's atmosphere, forming a halo around the planet. Seeing the surface in visible light is no small feat, given that Venus is permanently shrouded by clouds. Clouds obstruct most of the visible light coming from Venus's surface, but the very longest visible wavelengths, which border on the near-infrared wavelengths, make it through. With the red light mostly getting lost in daylight pictures, the hope was that a nighttime pass would allow the imager to see the heat of Venus glowing from the surface. A study based on the research was published in Geophysical Research Letters on February 9th. On February 25th, NASA announced the mirror segments of the James Webb Space Telescope were in place and their individual images stacking together. This completed 3 of the 7 stages needed to bring the 18 hexagonal mirror segments of the James Webb Telescope's primary mirror into final alignment. NASA then released an image of the target star used for this alignment, HD 84406, in the constellation Ursa Major. After moving what were 18 scattered dots of starlight into Webb's signature hexagonal formation, the team refined each mirror segment's image by making minor adjustments, while also changing the alignment of Webb's secondary mirror. The completion of this process, known as segment alignment, was a key step prior to overlapping the light from all the mirrors so that they could work in unison. Once segment alignment was achieved, the focused dots were then stacked on top of each other, delivering the light from each segment to the same location on the near-infrared camera, or NIRCam's sensor. During this process, called image stacking, the teams activated sets of 6 mirrors at a time and commanded them to repoint their light to overlap until all dots of starlight overlapped with each other. The entire Webb team is ecstatic at how well the first steps of taking images and aligning the telescope are proceeding, said Marcia Ricci, principal investigator for the NIRCam instrument. Software used for the image stacking was not known, but some astronomers have an idea. Astra, an American launch vehicle company founded in 2016, got some unwanted publicity last August when a launch of a military payload literally went sideways. Following a successful orbital flight in November, hopes were high for another successful flight.
Vehicle is clear to tower.
LV0007 has cleared the pad and is on its way to space.
After some delays, Astra's two-stage launch vehicle, LV-0008, lifted off February 10th from Florida's Cape Canaveral Space Force Station, carrying 4 CubeSats on a mission organized by NASA's Educational Launch of Nano-Satellite Initiative, or ELINA. The 13-meter tall rocket performed well initially, but ran into trouble shortly after stage separation, about 3 minutes into the flight.
Our stage separation. And that was MECO, or main engine cutoff.
At this point, a camera on the rocket showed the upper stage begin to tumble. LV-0008 was unable to recover from this off-nominal situation, resulting in the end of the mission and the loss of the satellites.
And thank you for standing by with us. Unfortunately, we heard that an issue has been experienced during flight that prevented the delivery of our customer payloads to orbit today. We are deeply sorry to our customers, NASA, the University of Alabama, the University of New Mexico, and the University of California, Berkeley. More information will be provided as we complete the data review, and you can follow along for updates on Twitter at Astra, as well as on our website, astra.com.
An investigation showed that 2 things went wrong during the February 10th flight. First, the payload fairing, the protective nose cone that surrounds the satellites during launch, didn't deploy properly. The separation mechanisms were fired in an incorrect order, which prevented the fairing from separating completely before upper stage ignition. The second problem was a software issue that prevented LV-888's upper stage engine from using its thrust vector control system, which allows the engine to alter how its thrust is directed. This led to the tumbling and ultimately the end of the mission. Astra has worked to eliminate the problems seen on LV-888's flight. The U.S.'s Federal Aviation Administration, or FAA, which is overseeing the investigation, still needs to approve the fixes. Once that happens, Astra aims to return to flight soon. Originally designed for 5 flights, NASA's Ingenuity Mars helicopter made its 19th and 20th flight on February 8th and February 25th, respectively. The 19th flight, which flew 63 meters, had been delayed by weather since January, as a dust storm was in the area. The storm had deposited dust on crucial parts of the rotor assembly that control the pitch of the blades, which is essential for stable and controlled flights. Sensors on the helicopter indicated the rotor assembly had stiffened due to dust. Controllers used the time to work a fix by cycling the assembly's actuators, which cleared the dust. Ingenuity flew 391 meters on the 25th, landing near the Perseverance rover. Controllers plan to use the helicopter to scout out the terrain in front of the rover as it makes its way to the ancient river delta in Jezero Crater. On February 18th, the Perseverance rover celebrated its first year on Mars. It spent its first year verifying all its systems and exploring the area around its landing site. In its next year, it will make its way to the primary target in the 45-kilometer-wide Jezero Crater, an ancient river delta that fed the lake which once filled the crater. If there are signs of ancient microbial life, the delta should be a good place to look. The nuclear-powered rover is in good shape and is expected to function for many years. Meanwhile, the Curiosity rover continues to soldier on in Gale Crater since it arrived almost 10 years ago. It chanced upon a curious feature in the Martian soil that resembles a flower, or perhaps a sea anemone. The time on Mars has been hard on Curiosity's tires, but it keeps on rolling. What if a tire fails completely? As the rover has no spare, or even a jack, maybe a tow truck could be sent. This guy doesn't look busy. The International Astronomical Union has launched a new center to fight the threat of satellite megaconstellations, which it now describes as worse than urban light pollution. The Center for the Protection of the Dark and Quiet Sky from Satellite Constellation Interference will be run jointly by the UK headquarters Square Kilometre Array Observatory organization and the US National Science Foundation's National Optical Infrared Astronomy Research Laboratory. Both these organizations are dealing firsthand with the fallout of the mega constellation boom. The next generation observatories these two institutions are currently developing will have their observatories compromised by satellite interference. While in the past the remote deserts of Chile, Australia, or South Africa could provide a refuge from the world's bright lights and buzzing communication networks, there is nowhere for the astronomers to hide from the thousands of satellites orbiting the planet. By the end of the decade, more than 5,000 satellites will be above the horizon at any given time, said Connie Walker, one of the co-directors of the new center. At a typical dark sky observatory location, a few hundred to several thousand of these satellites will be illuminated by the sun. These satellites, she added, will be detectable even by the smallest optical and infrared telescopes. Moreover, the amount of metal orbiting Earth will reflect so much light that the night sky will brighten up enough for the telescopes to notice, making observations of the most distant and dimmest stars and galaxies difficult. It's not just professional astronomers who are raising the alarm. Amateur astronomers and even casual stargazers can't get away from this traffic jam in the sky. This live sky map over Edmonton, Canada, shows a cloud of orbiting objects, most of them Elon Musk's Starlink satellites. The astronomy community wonders, what is the next abomination that will grace the nighttime sky? On February 7th, Elon Musk's satellite broadband project Starlink lost up to 40 satellites after they were damaged in a geomagnetic storm and re-entered the Earth's atmosphere. Satellites from a recent launch were caught up in this storm that didn't allow them to reach their regular orbiting altitude, resulting in them burning up in the Earth's atmosphere. A Starlink spokesperson explained, "Unfortunately, the satellites deployed on February 3rd were impacted by a geomagnetic storm on the 4th. These storms caused the atmosphere to warm and the atmospheric density at our low deployment altitude to increase. The escalation speed and severity of the storm caused atmospheric drag to increase up to 50% higher than during previous launches. The company insisted there was no risk of damage to other satellites in space or people on the ground." Elon Musk expressed disappointment at the loss of the satellites.
I was very sad to see that because those guys are, difficult.
In a more optimistic tone, he stated, "There's more where those came from." The Starlink satellites were not the first high-profile object to be brought down to Earth by solar storms. Intense solar activity in the 1970s increased the atmospheric density so much it caused the American Skylab space station to deorbit in 1979, years before it was expected to. It had been hoped the station could be visited by the space shuttle, which did not fly until 1981.
Okay, that is it. Stop share. All right, there it is. 10th, actually 11th issue, 1 year anniversary.
Well done, Jeff. And congratulations on your first year. I know how hard you worked to put those together, and we all really, really appreciate them. So let's give them a round of applause.
Thank you.
Very good. All right. Well, it's, I'm sure most of you are aware, this month marks the 90th anniversary of the founding of the RASC Edmonton Centre. And it's my honor to be able to introduce our guest speaker. Our guest speaker joined the RASC Edmonton Centre a few years ago, January 1st, 1952, to be exact. And so he is celebrating his 70th year as a member. So although, as he hastens to point out, he wasn't involved from the beginning, he certainly knew many of the founders of our club. Franklin was part of the committees that proposed the construction of the Queen Elizabeth II Planetarium, which opened in 1960, and later the Edmonton Space and Sciences Centre, which opened in 1984, now known as the TELUS World of Science Edmonton. Franklin was on council for many years and served as president of the Edmonton RASC Centre in 1961 and 1971. And of course, he would have been the vice president in prior years, and he was also treasurer for a time. He was the editor of Stardust in 1955, 1956, and 1957. He was the National Council representative in 1968, from 1972 to 1977, and from 1987 to 1996. He was the national RASC president from 1982 to 84, and was appointed as a fellow of the RASC in 2016. The RASC Edmonton Centre has named 2 awards in his honor: Franklin Loehde Award for Project of the Year, and the Franklin Loehde Youth Membership Award. And he was given the 2016 Bryce Hartwell Award for Excellence in Astroimaging. The International Astronomical Union has named asteroid 85121/1976 KF3 in recognition of Franklin Loehde's years of service to Canadian astronomy. I have to say that Franklin is also active on social media, including Facebook, where he is known for his strong opinions on the current state of society. I won't go into details, except to say that any day now, asteroid 85121/1976 KF3 is due to hit Earth. In summary, Franklin is and has been the very embodiment of the mission of the Royal Astronomical Society of Canada. And so without further ado, over to you, Franklin.
Well, thank you, Tom. I'm not too sure I appreciate all of that, but nevertheless, you know, when you fall in love with the sky in whatever manner that you do, it's something that hits you very strongly. And when you see something beautiful in the sky, the first thing you want to do is to share that joy that you have. And I think this is typical of any astronomer, whether it's professional or whether it's just simply an amateur. And I think that really stands out amongst a lot of the sciences, because the public has always been involved on the leading edge of spreading the good word about the beauty in the skies. And okay. Distraction. So what I wanted to do when I was asked to give this talk, I realized that it was a serious mistake, because what I wanted to do is to show people that from all walks of life, that people are excited enough to want to spread the word, and they want to bring that word to the public. And this is certainly true of the Edmonton Centre, the RASC. And what I was hoping to do, and really it's impossible in one evening, I wanted to show a lot of the people who moved the centre and the achievements that have occurred during these 90 years. I guess I didn't see this photograph before, a combination of photographs, but I guess there are a number of iterations of me, including some of the friends I met in the Amazon jungle, the squirrel monkeys on the Amazon River. And that was a trip that was really worthwhile. And to see the night skies there was something else. And of course, like with many things, I have a tendency to be slightly ahead of myself, and I sported a beard at a very early stage of my career. And the interesting thing is that when I shaved it off, the beard off, no one noticed the difference. Not one person say, "Oh, you've shaved your beard off." So somehow they knew me at a different level from just simply the things that I wore or had on my face. And I found that really remarkable. Again, when you see a person for the first time, there's something that stands out. And I thought the beard would be it, but I guess my tendency to ask questions and so on overrid that. And so the beard was apparently not very important. So obviously what you wear and so on is not as important as the person inside you. Anyway, this, if we could go on to say the following. After looking at all the notable history of Edmonton since 1932, I realized to acknowledge some of the bright lights that we have had in our society is a monumental task, because there's so many people who have been excited by astronomy, and as a result of that, have had a long association with the group. And so what I wanted to say before we started anything, I want to say something about the overall impressions of the centre history. First of all, in our case, it started with the academics in the city of Edmonton, that from the university and from schools with principals and teachers and so on, who had a very deep knowledge of the heavens, and as a result had the desire to come together to form a group that could be the vehicle for public education. And if you take a look at the next slide that we have, you saw in a moment, if you take a look, you'll notice a number of names there. Dr. J.W. Campbell, Professor E.S. Keeping, Dr. E.H. Gowan, and then Miss Mamie Simpson. In a moment, I'll get to them and show you how they approached the love of the skies and what they wanted to impart to the public. But going back to the general impressions, first of all, the academic love of astronomy was number one. The second was long-term commitment. The second was, the fourth is amateur and professionals alike. There was no distinction right from the very beginning, the difference between an amateur astronomer and a professional. that wasn't a label that we attached to people. Young and old alike, starting certainly with the example of the observers group that was formed a few decades later. And another, a strong relationship between the city of Edmonton through the Parks and Recreation and the RASC. In many ways, you could say that the center is bound at the waist with the city of Edmonton. And here is another aspect that's very important. Right from the very beginning, male and female were always present. It wasn't a bunch of nerds who were happened to be male, but we had women involved, and that had a profound effect on the entire history, as we'll shortly see. Because it involved more than just simply the nerdy stuff, but some of the beauty that was expressed in so many different particular ways. The socializing of the entire family. We had picnics galore during the summertime. Some of them were referred to as debaucheries, the summer solstice, and so on. Picnics, art expressed, music expressed, poetries were always present, and so on. And which meant that the center itself was founded on a very broad base, not just simply data driven, but rather beauty of the heavens expressed in different ways, and it persists to the very day. And as you'll see how this occurred and why our center in many ways is fairly different from a lot of the centers across Canada. The other thing that stood out was that their thinking in the center was always outside of the box. In other words, very unconventional and so on. So when you deal with a topic as stupendous as astronomy, astrophysics, and space travel, and so on, there are no limits. Literally, the sky is the limit. So you approach whatever is the flavor of the day in a way that reflects the thinking of the people. Example, for instance, when, as you know, we hosted the very first not Star Night, but General Assembly, we took advantage of the fact that during the previous year, that Edmonton was almost hit by the Bruderheim meteorite just on the north side of the city. And so the reason when we went to the General Assembly the previous year, we had signs up called Meteorites Like Albert Better. And so this we use for the purpose of selling the GA. So not only was it moved from Ontario for the first time, but it was also moved to the long week in May. So again, outside the box, we saw a desire to perhaps change the atmosphere of the old General Assembly, which was, I think, at that time called the At Home at the University of Toronto. So we thought maybe having it during the month of May and a holiday that we could get more people to attend, and having it in Western Canada, we could get greater participation from the West. Our second General Assembly was everything natural. And in other words, the beauty of nature is not only in the sky, but also on the water. Sharon tells me there's a problem with the hearing aid. Can you hear me all? Can you all hear me?
Yep, sounds good.
I can hear you.
Yeah, no
Can't
problem.
hear you.
Okay, I can only hear you through my iPad. I can't hear you from my hearing aid, but I hope I can speak clearly enough. The second General Assembly we want to show that beauty is not only in the sky, but also in nature. So, and you may not realize this, but we had a banquet in an old log cabin, which you know is on 99th Street on the hill going down to the river. And the menu of that was an expression of the beauty of nature. So the main course included things like roast borealis beaver, And so we had government trappers who had to remove beaver that were causing flooding problems and so on. And as a result, they provided us with 6 beavers that would feed an army and so on. And that was the main course, along with whitefish from our local lakes, and a consomme made from, if I remember correctly, it was Rocky Mountain sheep. And thirdly, Saskatoon berries, which are another part of nature that are appreciated by humans as well as birds and bears and what have you. And thirdly, and Anthony White of the Centre can remember this, that the two of us went to the university, to the General Assembly the previous year and dressed up as blue-eyed Arab sheiks and so on, and with bottles of Athabasca oil sand, and so they each received a little bottle, a memento of the riches of Alberta, which allowed us to do a lot of things that you were aware of, like through our casinos and so on. And then finally, the impact, when it was eventually decided that the recognition of the visit of Queen Elizabeth and her husband was going to be in the city, and the city council wanted to know what we should do to commemorate the occasion. It was at that time that one of our members, longtime members, Frank Page, suggested a planetarium, and a committee formed, and eventually it was approved by city council. But all of this required thinking outside of the box, and so I have to commend the Centre for all these things that have been done to make the Centre that we see today. Okay, can we go to slide number 2? Back to slide number 2. And the names are Dr. Campbell, to give you a little bit of background, he was the head of the map department for many years, and he was a driving force, and eventually as well as being the president of the Edmonton Centre, he became the national president as well. His sidekick was Professor E.S. Keeping, who was the assistant department head at the University of Alberta as well. And he and his wife were for a long time active in the Centre, as well as Dr. Campbell and his wife. His wife, Ruby, was a poet. And so that had an impact right from the very beginning. Silver Keeping had also had a great involvement in social affairs. Dr. E.H. Gowan was in the physics department. Again, something obviously makes a lot of sense to think of astronomy and physics, because physics being the fundamental building block of the universe and so on. Miss Mamie Simpson that you see there was unusual in that she was an academic at the university, a professor, but she was also the Dean of Women. Can you imagine, in 1932, in January of 1932, we had the Dean of Women being not only a member of the Astronomical Society, but also at the same time was representing the female side. And so you can see right from the very beginning, there was a picture of the Edmonton Centre, not only male and female, but academic as well as non-academic. Then if we can go to slide number 9, Sharon, Tom. There, if you look carefully, and if you have a pad, you can use your fingers to squeeze out, but Dr. Campbell is at the telescope that was eventually donated by our supernova of the Edmonton Centre, Cyril Waits. But the first observatory at the University of Alberta and Dr. Campbell, both at this particular telescope we'll talk about later when we talk about that supernova, Cyril Waits, and so on. Okay. Then I could say that Ted Gowan was also a president and so on, and was heavily involved in all of the activities going way back to January of 1932. And he was in physics, and he was the person that ran the observatory along with Dr. Campbell and so on Saturday nights. Okay. Then I want to mention that the only vehicle that Dr. Campbell had to impart the message about the beauty of the skies was through a newspaper article, slide number 10, called Astronomy Notes. And you can see slide number 10, Astronomy Notes. And this he did every week, and as a result, he could mention about the center and the various meetings and some of the things in the sky that were to be seen, and of course could mention, of course, when the observatory would be open. And so this reached a fairly large number of people. So people did eventually come out to the observatory after it was built. But in the meantime, he was able to reach people in the Edmonton area who read the Edmonton Bulletin at the time. Later on, Dr. Campbell asked me to carry it on, and so I did, and expanded it to the Medicine Hat News, the Calgary Albertan, and the Spokane Spokesman Review, who didn't have any astronomical group in there, and they could share in some of the beauty of the heavens at that particular time. Okay. Then in addition to those people like Dr. Grayson Smith from the physics department joined. Dr. Doug Crosby was not only in physics, but also in math. And he was a Rhodes Scholar picked. And after the war, he did his duty in the war. He went to England to impart on his Rhodes Scholarship. Jean MacDonald, a local Albertan and so on, was also a member. And she studied to get her PhD and then ended up at the Dominion Certificate Observatory in the late 1940s and eventually married the director. So the two of them were doing research in astronomy in Victoria. Then, to add to the breadth of the membership, Dr. Len Gads from the engineering department joined, became president as well, and he added a very practical aspect to the whole business of astronomy as well, to the center. Then we had another person coming from the countryside and so on, who was an interesting one. He was a teacher out of Sedgwick and so on. And he happened to discover the comet 1939D. I tried to look it up in JPL, but I couldn't see it with that designation, but it was recognized by the Astronomical Society of the Pacific when he won a medal that was distributed by them when anyone discovered a comet. So we had our first comet discovery from Dr. Lewis Smith, who joined in the 1940s. Then, of course, the big supernova that I was mentioning was Cyril Winks. And to call him a supernova would be very appropriate, to put it mildly. He did everything. He was a leading engineer in the new technology called the telephone. We now, of course, sort of would laugh at that, but it was a technology, as you know, developed by a Canadian who did a lot of his work in the Maritimes and so on, and perfected the telephone. And Cyril Winks was one of the leading people and was the person behind Edmonton Telephones, being one of the first municipal governments there to operate its own telephone service. He was a pioneer telescope maker. He made his own mirrors, he made his own telescope, and the one you see there is a good example. It got a lot of people excited. He was a grinder machine technician. He was a musician, and he was a science fiction writer, as you see here. Sharon extracted some magazine stores there, and you can see him listed Cyril G. Waite there. And so he was also science fiction there. I don't think we've ever known anyone to be involved in so many different activities at virtually the same time. How he could do it, and of course, unfortunately, after he donated his telescope, he became president of the Edmonton Centre of the RASC. Eventually, he died just like a supernova would normally do, rise to brilliance, and then, of course, then eventually die out. And so we only had a decade or so of him, but he did amazing things in a very, very short period of time. So we can all appreciate that. Then if we go to repeat slide number 9, we'll just do that for a moment, the UA telescope. If you look carefully there, and you can pinch out, Dr. J.W. Campbell there is in the center, and then Cyril Waite is, as you can see, is at the business end of the telescope. The tube itself was actually made of wood. So in other words, there wasn't a problem of putting your hand on the tube and causing all sorts of tremors inside the tube because it was made of wood. And his other telescopes were also made of wood as well. So he was everything. He was everything. Okay, and then if you go to slide number 4, and he was an incredible person because he had contacts all around the world. And as soon as his telescope and observatory was built outside of his home on the east end of Jasper Avenue near Canary Park and so on, he was able to get a cover picture on Scientific American. You know, the Scientific American has been around for a long time. But there he is, he's standing out at his observatory on the other outside, across the road from his house, and you can see the river valley down below. And on back of us, from this photograph, is Canary Park. And so it's an area that many of you are familiar with because you do get a spectacular view of the skies and the downtown at the same time. Slide number 5. Slide number 5 is the actual 12-inch that he built. He had it at his house, in front of his house for a while, but eventually it was certainly one that was an appropriate donation to the University of Alberta for their first big telescope. The small telescope you see at his hand there was used as our finder. And again, the optical quality was first class, without a doubt. Slide number 6 takes us to 1942. And you've seen this picture and various people. To the left of the center and off on the right side there with a white hat is Dr. Campbell, and various officials from the university and the University of Alberta, and also from the government. Cyril Waite is that jaunty looking individual with the blue blazer, the tie, and the white pants. He stands out, and he did in so many different ways. Jeff Robertson, as you know, has tried to put me in that group. I think he replaced the person in the very center with my face, but I was only 6 years old at the time, having been born in 1936. And since I had a tendency to wander from the house, one time I wandered from my house in the Highlands district and so on. And 3 miles later, I walked into a police station, and they had to find out who I was and call my mother and father. And so they wouldn't allow me in 1942 at the age of 6 to go to this opening at all because they're worried I might get lost and so on. But anyway, it was kind of sad. And I think Dr. Keeping, if I remember correctly, where you see Dr. Campbell there, Professor Keeping is the one just to the left of his, on his, I guess it would be his left shoulder in the background there is Professor Keeping. Okay, then, and then after during the 1930s, because of the telescope and so on, more people joined, including one very important person in the field of cosmology and quantum physics. And we were joined by Dr. Max Wyman from the physics, theoretical physics area, and he became president. And one of the distinguishing features about Max Wyman was that he wrote a letter to Einstein back in the 1940s, I believe, anyway, to Albert Einstein. And one of the papers that he wrote and pointed out an error that he had made, Albert Einstein had made, and so on. And Albert Einstein sent him a letter back and acknowledging, yes, that truly was an error in that particular paper. And so they became acquainted in that way. But another person who became president of the Edmonton Centre. Then, as you say, all hell broke loose because we had the introduction of a new group of people, the era of Ruth and the youth movement, and the Observers Group was formed in 1942. And this is one of their earlier photographs to show you some of the people who were involved. The person with the bow tie, the lower left there, is Arthur Dalton, who during the time he was in the center, he became very active in observing, especially planetary, but he also did a good deal of observing in things like the aurora, meteors, and so on. He during his late and early 20s and so on, he spent a lot of time slicing rat brains. And so even though he didn't choose to become an astronomer, he became an expert and researcher in Alzheimer's disease and senior citizen diseases and so on. And so he became quite famous and spent a good deal of his time in places like Toronto and on Staten Island in New York City. The person on the right-hand side there was Dick Henry, another one of our younger members and so on, and a brilliant individual. He was a member of the center, but at the same time, he got a lot of his high school education at some of the prestigious high school institutions in Ontario and so on. And because he was brilliant and so on, he eventually was taken up by Johns Hopkins University in the physics department there. And as a result of that, NASA recognized his value and appointed him the head of a committee that decided on which scientific projects should be part of the International Space Station. So he had a good. Up in the upper left-hand corner is Marcel Dalton, and he was also in the Highlands District and so on. His mother was a editor of a local newspaper called the Beverly Page and so on, and he was involved in various observing programs in the center. Next to him, towards the center, is Ian McLennan. Ian was interesting. He was also from the Highlands, and he was also from the same school as me, but in a different room. The principal deliberately kept us apart until grade 9, and so on, and for good reason, because he knew that we were astronomy nuts, and didn't want us to get together to cause too much trouble. Yeah, Frank, yeah, Ian's on the right, yeah, but he's on the left of me. But in the photograph, he's there in that position. And of course, what he did was a different perspective, because as he was growing older, he became very interested in photography, and from that led to a job at CFRT as a video newsman and so on. So his skill set was extremely important to us as time went on, when we developed the idea of the Queen Elizabeth Planetarium. Of course, I was in the center there. And next to him was another weird individual, also interested and extremely important in the development of the Edmonton Centre, Dr. Earl Milton. He came from the Montreal Centre. And the impact of the Montreal Centre on the Edmonton Centre was very proud, thanks to Earl. He eventually went to university and became really a doctor in chemistry, and then realized that he was in the wrong field and became a physics professor at the University of Stanford in Regina, and then eventually the University of Lethbridge. And I'll have a lot more to say about him later on. And John Mandrusiak was one of the observers who was actively involved in various programs. This just is a small part of the early group. Okay. Next, where do we go? And the next slide is very pivotal as well. The members of the academic members of the University of Alberta. Okay, we'll get to this one in a moment. Slide number 12, I was going to point out, was the key one. Here's the Waits Telescope at the University of Alberta. We helped out, the various members of the observers group helped out on Saturday evenings with the public showing at the University of Alberta. And eventually the observers group was given the full task of showing the public the beauties of the sky, and was also used, of course, for things like observing the planet Mars and Jupiter and the various groups that were formed. So now I have to say here that the academic group were incredibly supportive of the young kids in the center, and that support carries on to today as well. And what happened as a result, we were given full reign to do anything we wanted. So slide 14 was an example of the very first thing we did. Slide number 14, which is the 15, the Stardust. Sorry. Because again of the Montreal Centre's influence on Earl, and in turn Earl on us, we decided to have a newsletter. Except there was no such thing as Steppners, mimeograph machines, or anything along that line. But in the October of 1954, Earl and I were able to put our first publication out, called Stardust, appropriately, and so on, with a comet. A comet there is the headline. This is our first issue, our very first issue. And because you'll notice the date was October 1954. And how many of you know from the history of the Edmonton Eskimos what happened in October of 1954? Can you guess what happened in October of 1954? The Edmonton Eskimos won the Grey Cup. And of course, against what team? The Montreal Alouettes, and so on. So we got to dig in the next issue. We made sure that somewhere in this area we had home of the Grey Cup. Please notice Montreal. so we got a little dig at Montreal. But again, the importance of Montreal was certainly there. Okay. Then Then we had another thing that Earl brought up that was extremely important, and that is what was done in Montreal. We had various observing disciplines with each with its own chairman and so on. And to give you an example of some of those early disciplines, one was the Aurora. Earl established an auroral network, so we sent our observations to Earl, and then Earl in turn at one time sent them to Dr. C.W. Gartland at Cornell University. Here's Earl. Thank you, Sharon, or whoever picked it out quickly. And as a result of that, the Chant Medal was awarded to Earl for his study. And because of the quality of the work that was done, when he was at the PhD level, he was able to get his postdoc with Dr. Gerard Hertzsprung at the National Research Council and so on, who was another very unusual individual who's not only a Nobel Prize winner, but also at the same time was a person who thought outside of the box. Then after the solar division was formed, and at that time the AAVSO solar division was involved, and my being interested in the sun, I used my 6-inch telescope that my dad helped me to build with a solar fan base coming from where he worked. And I spent 10 years during the most stupendous solar maximum ever in 1957-8. But I accumulated with my 6-inch telescope in my backyard, surrounded by all the vegetable garden that my dad, being a horticulturist and so on, or agrologist actually, and so on, back in Germany where he went to university, and I did my observing. I got my report sent to the AVSO, spent 10 years doing it, and I got rather high counts. And I must put a warning out right now here, don't do this at home. The reason I had high counts, as you can see, I was exposed, no observatory, and I couldn't use a projection method for the purpose of recording the sunspots. So what I did, I used a number 12 welder's glass and so on, and quickly moved it in front of the eyepiece. And of course, that's extremely dangerous. And of course, you could lose an eye. I didn't do a lot of staring, but as a result of moving that back and forth, I was able to achieve a very high sunspot count. And only on one occasion during that 10 years, during the coldest of winters and so on, did the welder's glass break. But fortunately, it didn't hurt me. And I lost a little bit of color perception in my left eye. But other than that, but again, I warn you, don't ever do that. I was stupid enough to do that, but you don't have to do that. Okay. Then as a result of that, the solar division people at AAVSO sent me something that I used in later, was a device that would detect solar flares, using, of course, the enhanced standing of the ionosphere. And so as a result, radio signals could bounce off for quite some distance. And so I set up a project at the university farm with a paper recording device, and the device that was used to detect the radio signals and so on. And what I thought was initially interference was actually that I was using the signal coming from a submarine base outside of Seattle, and which turned out to be rather interesting, as Paul Paul mentioned that he was able to observe gamma ray bursts. Another first for the center was observing gamma ray bursts using essentially the technique. And Paul Campbell recognized that those signals coming from Seattle, the submarine base, was not interference. And I did notice from my charts at the time that you did see a very quick ascent to a maximum strength of signal and then tailing off. And so Paul Campbell really deserves a lot of credit for discovering gamma ray bursts, but not too many people know about that. Another thing was another observing group was the planetary division. And this was originally, I think, run by Ian. And the observations were sent to the American Lunar and Planetary Society and so on. And during this particular period of time, since we're all interested in the thing, Ian really demonstrated what he was eventually going to do, and that is go into the entertainment business. Because during our time in junior high, he built a telescope of a cardboard tube and used a stepladder to hold it together, and had a lens, of course, stuck at the end. And then he tried to convince me that now he had taken this picture of the moon, and I saw that, and it didn't quite let. And so I had my first demonstration of fake news, but realized that Ian would eventually get into the entertainment business by becoming the director of the Queen Elizabeth Planetarium. And so he demonstrated his skill was telling people about the beauty of the skies, even if it's a little fake. Okay, during this particular time, I was in touch with Clyde Tombaugh on slide 20. And so I sent a letter to Clyde Tombaugh, and as you can see here, dear Mr. Loehde, I'm not too sure how old I was, but I was probably in high school. I think I was in high school. Anyway, I sent a letter to him, and he graciously indicated that I was glad that I was interested in Mars and so on. And it's interesting, something like 20 years later, Clyde Tombaugh was invited up to Edmonton, and we had dinner with him. And they never got around to telling him that I was this geeky individual that I had contacted back so many years ago, September 1956. But he was very nice, and we happened to see him in Edmonton when he eventually visited. Another person I contacted because I was interested in the planetary work was slide number 21. And that was from Mishiro Ebisawal. As you can see, the quality of his drawings were spectacular, to put it mildly. But he sent me quite a number of photographs. All have been sent to the archives as well, and so on. But here's a photograph of the quality of his work and so on. So our observers group had a chance to take a look at what he could do, and we tried to do something similar, but of course failed rather miserably. But it was a good start. In number 23, gives you an example of a composite map of what we did. So the observers of Dalton, Milton, and myself, I put them all together to produce my map of Mars. And as you can see, it's pretty crude. We even had canals practically, you can see there. But you can see Sirius Major and Solus Lacus and so on. But it was an interesting attempt with a Mercator projection, of course. And that's all you could do to that piece of paper. But because of the excitement of what we were able to do, we then went to slide number 24. And because they, 24, I think, is the Calgary Albertan. Let's go back. There we are. Okay. Because of the astronomy notes and so on, some of these people knew us, and the Calgary Albertan, which was the main newspaper at the time, were quite interested in seeing what we could do. This was before the Calgary Centre was born, and so we got the front page of the Calgary Albertan, and with the silly map that you see there that was put together with the 3 observers and so on. And so we got a nice acknowledgement, and hopefully maybe that was seen by some of the public in Calgary, and led to eventually to the birth of the Calgary Centre. Okay, 5, number slide. No, there's no slide. The photography division, as I said, was in charge by Ian, and provided that fake photograph, and eventually it caused him to become director of the Queen Elizabeth Planetarium. I should add, to redeem himself, he established the 53rd Street Proving Ground, which was our rocket launch site across the street for him on 53rd Street and so on. And so Ian and I were able to get a source of fuel with acetylene gas as the driving force, and we got liquid oxygen, and stuck 2 cans together. Talk about primitive. 2 cans together, and we had an 8-inch mirror that was provided to us by our our high school assistant principal, who had an 8-inch mirror, but he never got around to finishing the telescope. We were going to use the liquid oxygen and the acetylene gas using calcium carbide, I think it was a chemical, and combine the 2 of them, and then ignite it with the 8-inch mirror. Of course, it didn't work. The temperature never got high enough. And so while we were fiddling around trying to ignite our rocket, we eventually decided to use a match. By this time, of course, the acetylene gas and the liquid oxygen had a chance to not only disperse and mix up properly, but spread quite around. So I went with a match and came close, and it exploded with a sound so loud that I think neither of us could hear for a couple of days and so on. So again, don't try this at home. But when you're young and stupid, it's something you can get away with. Okay, then another area where we attempted to do some work, and that was in meteors. And Earl took charge at the beginning, and sent the observations to Dr. Peter Millman at the NRC. Dr. Peter Millman was one of the people that was a national president and so on. But so we had counts of the meteors there for quite a number of years as a result of it. And eventually this became an integral part of the observing program in the Edmonton Centre. Next was comets. Comets were fairly uncommon, and then a spectacular one appeared in the sky, discovered in, I think, in 1956, but by 1957, in the month of July, it was going to be visible in the northern sky just above the northern horizon in Edmonton. So this means that anyone further south would, of course, find it below the horizon. But we had a particular advantage. So for this reason, we set up our telescopes in various locations around the city and so on. And I was lucky enough to be able to spot it and make a number of observations with it. And as a result, discovered something that was not known to many of us at all, including within the professional community, and that it had an extra tail. And it was referred to as anomalous tail. And eventually, of course, we knew that the 2 tails that the comet had at that time were the iron and the dust trail and so on. One pointing away from the sun, which was well known, And the other one was the iron tail. And we could see this unusual thing and notice the change in its position as time went on. Unfortunately, all the drawings and so on of the comet are to be found in the provincial archives, so we can't show it here. I don't think. Do we have the side of it? No, I don't think so.
No,
Okay.
no.
Let's go on to the next. Okay. I mentioned the geophysical year. Slide number 13 was an example of the slide number 13, the Great Debate, and at that time, you had to understand that interest in astronomy was getting stronger and stronger because of the introduction of space travel and so on. To give you an example how impactful it was at that time, in grade 9, my father had a friend who was a teacher out at Bonaccord, just north of the city. And she asked me to give a talk to her grade 9 class. And so I said, okay, sure, I'll come out. I had to skip school, of course. I didn't tell anyone, but I skipped school, I guess. And but I thought at this time I had known Ian and said, well, why don't you come along and so on. Anyway, we got there expecting to give a little talk to her grade 9 or grade 8 class. What had happened, as soon as the teacher mentioned this to the principal of the school, the whole school gathered in the gymnasium from grade 1 to grade 12. So from 9 o'clock to 12 o'clock, we were talking about the beauty of space and the introduction of space travel that was soon to become very well known. And as a result of that, the whole school turned out and were asking questions right from 9 o'clock to lunchtime, and they still wanted us to come back for an hour after lunch. The enthusiasm was that great. The photograph on the right was an interesting one, again showing the partnership between the young and the old, the professional and the amateur. Over on the left-hand side of the photograph is Professor Keeping and myself, and then Art Dalton and Dr. Grayson Smith. Physics and math, the youth as well, amateur and professional. Unfortunately, Professor Keeping and myself lost the bet, and we had to argue that space travel is not going to be possible. Art and Dr. Grayson Smith had so they had the better of the deal. But again, because of the interest in space at that time, the debate was recorded dutifully in the Edmonton Journal, as you can see here. It was an extraordinary period of time when the interest was just unbelievable. And of course, if you take a look at the date there, I think it's, what is it, 1950? I can't read it very well.
1953.
What does it say? 53?
1953, I think.
53.
Oh, it says,
okay.
or 55.
Yeah, okay, 1953. And as you know, at that time, one of the big, some of you might know if you're old enough, that one of the favorite magazines at the time down in the States was one that made use of some spectacular paintings made of Jupiter and Saturn and so on, and text by another great writer of space and showing space travel, space station, and everything else, and so on, and that caused a sensation. And then within a few years, guess what appeared in the sky? Sputnik. 1957. The world was abuzz as a result of the Soviets beating us to the punch and launching the first artificial satellite. And then shortly after, the Laika, the space dog, and so on. So people were taking photographs, listening to the signal coming from these satellites and so on, taking pictures and so on. So it was an era in which it was hard to match. People were just absolutely keen, and everyone was watching the sky and so on.
Franklin,
Okay.
Franklin,
Yes.
I think this is a perfect spot to stop. We're going to divide your
Yes.
talk. We're going to divide your talk into two parts, and we're going to ask you to come back for our next members meeting and do part 2 of your presentation. This has been just incredible. It's going to go into the archives as a great oral and pictorial history. But I want to leave about 10 minutes or so for questions for your presentation that you've done to date, but it's just been fantastic. So, and I want to thank Sharon. I know you want to thank Sharon too for all her assistance with this. So we're gonna
Sure.
we'll split it into two parts, and we'll do, you know, RASC Edmonton Centre during the space age for the next presentation.
Okay, yes, and perhaps one of the biggest things was the Operation WHAM, the Wamma Hunt for Aqua meteorite, showing our first attempt to recover a meteorite. And that was a prelude to eventually the Bruder High meteorite, where it was done professionally. Amateurs first time, professionals next.
Fantastic.
Okay, then.
You did a great job. Let's give them a round of applause.
Ooh, thank you.
Sorry, it was a great experiment anyway, but there's just too much.
It's not over
There's
yet.
just too
It's not over yet. We're going to get you to come back and finish up the history, which will be great.
I think that's a wise move to separate like that. Good. Okay.
So, are there
Thanks.
questions? Are there questions for Franklin on the first? Well, it would be the first 35 to 40 years of the center.
Brian has a question.
It's Brian. Can I ask a question?
Yes.
Sure. Go ahead.
I noticed on the program for the meeting in Edmonton that there was a visit to Minook. Did you go on that visit?
Of course.
We in Newbrook at the sister observatory for that have all the Minook equipment installed in Newbrook.
Right. Yes. No. The Edmonton Centre had the directors of the two observatories. And this, of course, comes later. Comes later than the time period I've just covered, and so on. But Jack Grant at the Minook Observatory, he was a big influence on the two of us. He did some remarkable things in photography, time-lapse photographs and so on, which we had never seen before. And again, this was part of the legacy we had in the Edmonton Centre. But that comes with the development of the telescopes for military purposes initially, but then for tracking satellites and so on. But yes, very much so.
We were
We'll talk
lucky to
about
be
that
able to
later.
find the equipment. And as I say, we've reinstalled it in the observatory, the original observatory in Newbrook.
Yeah, I haven't seen the one in Newbrook, and I don't think Ian has either, but we were mostly associated with Jack Grant, who ran the facility at the Minook Observatory.
Right.
And as a matter of fact, it was that observatory with Jack Grant who was part of the tour at one of the General Assemblies.
Yeah. In the Newbrook site was the one where they got the first photograph of the original Sputnik.
I believe so.
Yeah, there's
but
pictures in the
I won't,
building.
I won't say for sure, but you may be right on that.
Yeah, there's pictures of the mounted frame, pictures of the image in the observatory in Newbrook.
Yeah, and that was a project there at Newbrook that was spurred on by one of our members as well.
Yeah.
But thank you for that.
I'm curious, Franklin, what kind of observations of the aurora were you being asked to make, or were you contributing at that time? Then what was what would a standard aurora observation report consist of at that time?
Oh, okay. As I say, the aurora observations were in Edmonton were started by Earl Milne, and the original observations were sent to Carl Gartland at the Cornell University in New York State. Then it was transferred to the National Research Council with Peter Millman. Peter Millman, I believe, was responsible for the construction of a device I tried to give to the archives, but they wouldn't accept it. And I think it's still in the library of the Edmonton Centre, but a little mechanical device which allowed you to slip in a card and hold it in such a way that you could measure the height of the various auroral arcs, which are, of course, the most common start of auroral displays and so on. And these were then sent to Dr. Millman in Ottawa at the time. But all the other reports that Earl used in his aurora network around Western Canada were done just simply ordinary sketches and, auroral arc at 5 degrees without any direct measurement and so on. But certainly the distribution of aurora over a long period of time were still useful for our understanding of the aurora. But I'll tell you something. Despite the fact that the solar maxima has been going down steadily since 1957-58, my impression, I could be wrong, but my impression that the auroral sky is ever so much more active than it was back at that time. I'm serious about that. The aurora was frequent, very, very frequent. Most nights you could see aurora, but the extent of the displays that you have now far exceed what you had at that time. So it doesn't make a lot of sense. Of course, you associate aurora with large spots and solar flares that are associated with that. But even though we've been going down in the frequency of sunspots and solar flares, nevertheless, the sky is much more electric. And it's amazing. Even the appearance of noctilucent clouds is following the same thing. Noctilucent clouds were always well known in Scandinavia, but not in Canada. The first time I saw it was in the early 60s, one time from the Strathern district and so on. But we didn't see them every year. Now, of course, we're a hotbed for noctilucent clouds, as you know.
I was going to ask that as well, as to whether you were seeing noctilucent clouds very often back then, whether that was something you just always saw, or is it a more recent?
No, it's all new. And I want to mention this because Earl, because he was a thinker outside the box, I have to point out a little bit of history. When Velikovsky came and collected the legends of the sky reported by different cultures around the world, his first book, was placed in the astronomy section at the public library, the Carnegie Library that existed downtown. And he was so upset. He was almost apoplectic and so on with his disgust with this and so on. And little did we know, after condemning the library for daring to put this into the science section of the library, that he would become the biggest converter, like a converted Catholic, so on. And he became an advocate of essentially an electromagnetic universe and so on. And the legends around the world are so consistent about the sky. People in the ancient days were much more excited about the sky than we are. We didn't build pyramids. We didn't build Stonehenge and so on to support the position of the sun in the sky. To the people in the past, the sky was alive, really alive. Today, no, that's not the case at all. Nothing to come in. We don't build edifices to the sun anymore, or to the moon, or the star. But they did at one time. And so I think the electrical magnetic universe is being understood more and more all the time. I'll give you an example of where orthodox thinking is not very desirable. When I worked at the Diminas Physical Observatory in my second year, I worked under Dr. Andrew McKellar. He was one of the, he became eventually the head of the observatory in Victoria. I was working with him, talking with him, and he had discovered back in those early days that comets revealed a hydrocarbon presence and so on. And he had a hard time admitting that because he was roundly condemned by everyone. Oh, that's silly. There aren't any hydrocarbons on comets and so on. But nevertheless, he detected them at that time. Unfortunately, I didn't follow up with him and he died the next year. But the fact is that he was one of the very first people to discover the presence of hydrocarbons on comets and so on. Now, of course, what are we to talk about? We're talking about, oh gosh, hydrocarbons on the satellites of asteroids, of comets, on the moons of Jupiter and Saturn and so on. How times have changed. You have to have people who think outside the box. Right?
Yes, that's what science is all about.
Well, it is, but it's interesting. It's also true in business. People go to university to learn about, say, computing science and so on. But if they stay too long, they get bogged down in the orthodoxy of the time. So most of these people who build computer empires and so on spent a year or two at university, but they're carried on by the idea of computing science, what it could do. So they quit. If they stayed any longer, guess what would happen? They might be brainwashed into thinking that all the things that they had in mind were not possible. So it's the same thing.
There's only one thing that can kill science, and that's certainty. Are there any other questions for Franklin on the first 30 years of the center?
Okay.
Okay. Well, listen, Franklin, that was fantastic.
That was great.
Fantastic. Yeah, let's give him another round.
Very disjointed. That's
We'll have Franklin back, as I said. We'll schedule him for the next members meeting or members presentations would be a logical place to have Franklin do part 2, and who knows, maybe part 3. We'll see how it goes. We've got a couple more things on the agenda for tonight. One is we're going to have another presentation of music from Orla, and he puts the A in STEAM. So we're going to enjoy that. It's called The Stars Belong to Everyone. And then we're going to have Abdur with Astro Imaging Corner, and then finally some closing announcements, if there are any. So Orla, where are you?
I think I'm here. Can you hear me?
I can hear you. I can't.
I've been having some problems with my microphone, but I'm hoping it's working.
Yeah, we can hear you fine. Your picture's good.
Okay. Well, good evening, everyone. I'm going to present my 4th installment to this group. My songs on science music videos that I have been creating over the years. Following Franklin's, well, I thought this would be appropriate to present this particular piece tonight because of Franklin's historical view of our center. This music video deals with a bit of RASC Centre history related to the declaration of the Beaver Hills Dark Sky Preserve. And what I need to do, I guess, is share my, stop sharing. Let me share again. I have to share sound and optimize, and then pick something to share.
The stars belong to everyone.
I dedicated the song Stars Belong to Everyone to the Beaver Hills Dark Sky Preserve, which was established on September 3rd, 2006 at Elk Island National Park. I performed the song at the first anniversary of the preserve on September 2nd, 2007. In case you are unaware or have forgotten about this historic event, I present here the official declaration from 2006. In a cooperative initiative to conserve the natural dark sky as part of our heritage, Parks Canada Agency and Alberta Community Development, in partnership with the Royal Astronomical Society of Canada, hereby designate the Beaver Hills Dark Sky Preserve, including Elk Island National Park of Canada and Cooking Lake Blackfoot Provincial Recreation Area. Together we recognize that the natural darkness is an ecological resource in need of protection and are committed to responsible lighting practices that preserve the beauty and wonder of the dark sky above these parks. This designation, during Elk Island National Park of Canada's centennial year, builds 100 years of conservation and echoes the original spirit of cooperation and commitment to preserve the environment. These efforts are acknowledged and committed to with the signing of this document, this third day of September 2006 at Elk Island National Park of Canada. The document is signed by Marilyn Peckett, Superintendent, Elk Island National Park of Canada, Parks and Canada Agency, Roger Rylander, East Central Area Manager, Alberta Community Development, Parks and Protected Areas, and Scott D. Young, President of the Royal Astronomical Society of Canada.
The stars belong to everyone.
Also, the title of my song is in memory of Helen Sawyer Hogg, an American-Canadian astronomer who pioneered research into globular clusters and variable stars. It is taken from the title of her book, The Stars Belong to Everyone, which was published in 1976. We can glean a bit of Dr. Hogg's accomplishments from this 1981 vintage interview with RASC's Randy Atwood.
Hello again, and welcome to Astronomy Toronto. My name is Randy Atwood. This show is produced by the Toronto Centre of the Royal Astronomical Society of Canada, where we look at the activities of both professional and amateur astronomers here in the Toronto area. Today I'm very pleased to have as my guest Dr. Helen Hogg of the David Dunlap Observatory, who has written this book, The Stars Belong to Everyone, which should be required reading for anyone who's interested in astronomy. Hello, Dr. Hogg, how are you?
Greetings, Randy.
A bit about Dr. Hogg. She studied astronomy at the Holyoke College in Massachusetts and just recently attended her 55th reunion. She attained her PhD at Radcliffe College at Harvard, where she worked with Dr. Harlow Shapley on globular clusters, and that's been her interest and her work ever since. Her husband, Dr. Frank Hogg, was the first to receive a PhD from Harvard, and Dr. Hogg moved to Toronto to the David Dunlap Observatory of the University of Toronto, which is situated in Richmond Hill, in 1935. Dr. Hogg is the Professor Emeritus of Astronomy of the U of T, and in both 1968 and 1976, she received the highest rank of Companion of the Order of Canada. So we're very, very happy to have you here today. By the way, she's also the Honorary President of our Royal Astronomical Society of Canada.
Yes.
Well, today we're going to be talking about
All the stars will shine tonight all over the world, and all eyes turn to the sky all over the world. When we extinguish all earthly lights and see the glory of the starry night, everyone will cease to fight all over the world. When people see the darkness fall all over the world, they will grow amazingly tall. They will reach up to the sky and learn the reasons why all the angels cry all over the world. In the darkness of the night, we all come to see what the world should be. The stars belong to everyone all over the world. Can you imagine if they were gone? Our children would not ask us why. Comets wander across the sky. They could not hear the angels cry all over the world. And in the darkness of the night, they would never see what the world should be. So let the stars shine every night all over the world, and let all eyes turn to the sky.
Thank you.
Yay, that was
Thanks.
good.
Orla, that was just beautiful. Thank you so much.
Thank you. You're welcome. It was fun putting it together.
Well, from the audio to the visual. And Abdur, I'm going to send it over to you, and I will make you a co-host.
Thank you, Tom. Okay. Just going to share my screen. Okay. Can everyone see that?
Yep, I can see it.
Sounds good. Awesome. So welcome to Astro Imaging Corner number 117. So we didn't have one last time in February. So we decided to include the images from that time over here as well. So I think I got all the images this time, but if I did miss anything or if I wasn't able to show your picture, just send me a message and I'll make sure I add it to the next one. So for anyone who might be joining us for the first time, the Astro Imaging Corner is the section of the regular meeting where we show images taken by our members. So you can, if you want to submit your image, you can send it to Astro Imaging Corner at edmontonrasc.com, or you can send it to me directly by email or Facebook or whatever you prefer. And the link for this is also on the RASC Edmonton Centre website at the bottom left corner where it says Astro Imaging Corner. So our first image of the night is from Arnold. This is the whale and hockey stick and crowbar galaxies. So at the top right, you can see the whale galaxy, NGC 4631, and its tiny little companion, NGC 4627. And these are in Canis Venestici. I'm not sure if I pronounced that right. But NGC 4631 is an edge-on spiral galaxy, which appears slightly distorted due to the gravitational interaction with its satellite galaxy, NGC 4627, that's the little one. And the pair has a visual magnitude of 8.89. And NGC 4627 is a dwarf elliptical galaxy. And the two galaxies are listed as ARP 281 in the ARP catalog of peculiar galaxies. And at the bottom of the image, you can see NGC 4656, which is highly warped due to its interaction with NGC 4657, which is a tiny little galaxy just off the edge of that hockey stick. And because of this interaction, it's called the hockey stick or crowbar galaxy. And this is one of my favorite pairings of galaxies in the sky. So thank you for this great image, Arnold. And up next, we have the Silver Needle galaxy. Also in Canis Venestici, and this is NGC 4244, also known as Cladwell 26. And this is an edge-on spiral galaxy, and it's part of the Messier 94 group of galaxies. And it's relatively close to the local group, which contains the Milky Way as well. And our next galaxy, also from Arnold, is the Needle galaxy, and this is in Coma Berenices. And this is also known as Cladwell 38 or NGC 4565. And this is the Silver Needle galaxy is often confused with this edge-on galaxy. So the Silver Needle galaxy and the Needle galaxy are two separate ones, and I've myself confused them many times for each other. But this one has a prominent central bulge, and it's one of the most famous edge-on galaxies in the sky. And it was discovered by William Herschel in 1785 and is considered by some sky enthusiasts to be one of the most prominent celestial objects that Charles Messier had missed. And it has a visual magnitude of 9 and an apparent size of about 16 arc minutes by 3 arc minutes. And a large dust lane cuts across the nucleus of this galaxy above. And it's the brightest member of the Coma group of galaxies. And all three of these images from Arnold were taken with the RASA 8 and the ASI 294 MC Pro. And they were cropped so the field of view is about half the RASA's 2.8 by 1.8 degree field of view. And these were all shot at Unity again using 60-second sub exposures. And they were approximately 45 subs each. And up next from Ray, we have the Cone Nebula. This was taken with the William Optics 132 millimeter triplet mounted on an Ioptron SEM60 mount. And Ray was using a full frame QHY 367 camera and an Optlong L Extreme filter. And this was stacked and processed in Lightroom, and the image was 60 minutes, which was 6 subs of 10 minutes each. So great shot there. Just got to get this out of the way. There we go. And up next, also from Ray, we have the Heart Nebula. And this was shot with the same William Optics 132 millimeter triplet. And this was also 1 hour of exposure time. And the last one for Ray, this is the Andromeda Galaxy, and this was taken with the same setup, except in this case, Ray was using 300-second sub-exposures, and he used the Oplong L Pro filter instead of the Oplong L Extreme. So very nice detail in those dust lanes there, Ray. And up next, we have an image from Dave Mussel. This is the Rosetta Nebula, or Rosette Nebula. Dave tells me that this one is his most recent image and the first successful narrowband image of the Rosette Nebula. And this was taken over 2 nights in late February and consists of 4.4 hours of data from hydrogen alpha, oxygen, and sulfur 3 nanometer bandpass filters. And this was all calibrated, stacked, and processed in PixInsight. And the telescope that Dave was using was a 5-inch Explorer scientific refractor reduced to f5.2 with a reducer corrector. And Dave was using his new QHY 268M filter, M camera, and a medium filter wheel. So excellent definition and detail there, Dave. Up next, we have an image from Alistair Ling, and this is Comet C 2019 L3 Atlas. And in this case, Alistair was using his Canon 5D Mark III at ISO 200, and Alistair was using a 300 millimeter f4.5 telephoto lens. And this is a total of 24 minutes of exposures, and each individual sub was 2 minutes. And this was actually shot from suburban Edmonton, Alberta, with fresh snow on the ground, which, as you might remember, reflects a lot of light. So from light polluted conditions, it's quite amazing what you're able to capture with some dedication. So thanks for sharing that, Alistair. Up next, we have another image from Alistair, and this is the January 18th full moonrise from Valley View. And for this shot, Alistair was also using his 300 millimeter Canon telephoto lens. And this is a panel of 2 high dynamic range images. So you can see detail both on the surface of the moon and the foreground. So beautiful colors there. And up next, we've got 2 more comets from Alistair. So in the left image, you can see Comet 67P, and the cluster up there is NGC 1758 near the center. And this was taken with the same 300 millimeter lens at f4.5 using the Canon 5D Mark III from Tollfield, Alberta. And on the right side of this frame, you can see Comet 4P, and the comet is actually in the upper left, so right over here. And Orion's 37 cluster is in the center right, and NGC 2194 is at the bottom center. So that's this, I guess, open cluster over here. And at the upper right, you can see the Bright Nebula Sharpless 261. And this was shot with the same specs as the previous image. And up next, we've got another galaxy, and this one is from Denis. And Denis says in this case, he tried to push the image a little bit to show some really faint stars, and he was able to get stars up to magnitude 19. And this was taken with his William Optics 132 triplet at f5. And this is a combination of 20 150-second exposures, and it was all processed in PixInsight and Corel PaintShop Pro. And you can see that IC3582, the oval, just slightly above the center of 3 smaller stars, so right over there, I believe. And Denis said that this is not in the right place in Guide 9, but the Loehde catalog shows it in the right place. And it's instead another galaxy, which is magnitude 17.1. And the bottom 3 stars on the left edge are magnitude 19.2. And at 2 o'clock, you can see another galaxy that is magnitude 17.8. So it's some really, really faint galaxies. You can see some really nice detail in that dust lane near the central bulge there. So great job, and thanks for letting us use that for tonight, Denis. And up next, we have my shot of the Andromeda Galaxy that I'd shared in the Astro group. And this was one of my most recent shots, and this is probably one of my first real shots after I managed to get the stars all round in all corners of my frame. So this is pretty much the entire frame with only just very, very minor cropping on the edges to get rid of some of those stacking artifacts. And this image of the Andromeda Galaxy was taken with my C11 at f2 using Hyperstar. And I was using an ASI 1600 mm camera with a ZWO filter and filter wheel. And I believe this was a total of about 3.5 hours of exposures that I ended up using. And you can see the two companion galaxies along with the dust lanes, and you can see some of the red regions over there, which are the hydrogen alpha regions where a lot of star formation is going on. And then along the edges, you can see those bright blue regions with a lot of really, really hot younger stars. And in the next image, you can see a bit of a close-up there. So in the close-up, you can see some of the hydrogen alpha regions. And one thing I recently found out was that you can actually see individual stars in other galaxies. So that's one of my longer-term projects, or I guess medium-term projects, is to image stars in other galaxies. And in this image, it might be hard to see on a smaller screen here, but one of the stars, which is this one right over here where my cursor is pointing, if you could see that, that star is actually the Cepheid variable V1 that Edwin Hubble had used in the 1920s to figure out the distance to the Andromeda galaxy and show that it's not in our own galaxy, it's its own island universe. So that gave us a better estimate of the size of the universe. So the period of the change in brightness of a Cepheid variable is related to its brightness. So that allows us to calculate the distances to other galaxies by identifying individual Cepheid variables in those galaxies. So I reprocessed that image today. So using drizzling, I managed to increase the resolution by 4 times, or the image size by 4 times. So the new image I'll be sharing at some point is a big 51 megapixel compilation. And on Wednesday, I'll be doing a presentation on how I processed this as well using PixInsight. And my next image over here, this is one of mine as well. This was the Leo triplet. And this is a small group of galaxies about 35 million light years away in the constellation of Leo. And it consists of the spiral galaxies M65 and 66 and NGC 3628, which is the Hamburger galaxy. And in this image, actually, you can see some of the quasars just underneath the Hamburger galaxy that are, I forget, I think some of them are probably 8 or 9 billion light years away. I'll have to look up the specs again because it's been a really, really long time. But this is a really, really interesting region of the sky. And I was able to visually observe this region from my backyard recently as well. So beautiful region. And this was one of my images of the crater Copernicus from last week. Considering the seeing is notoriously bad during the near the mountains over here where I live now, when I heard that the seeing is going to be average, I was out there in a minute, all set up trying to take some images. So this is an image of Copernicus. I don't remember exactly when I took this video, but I think it was fairly recent, and this was with a 16-inch Dob and my Fuji X-T2 camera. In video mode, and I just captured lots of 1080p video frames and stacked them. And Copernicus is 93 kilometers across, about 3.8 kilometers deep at its deepest regions. And those central peaks that you see are about, I think, 1.2 kilometers high in total. So quite a bit of detail in the walls of the crater, which is what I always wanted to capture ever since I saw a picture from the Hubble of that crater. That was the last of mine. So thank you very much to everyone who sent in some images, and I hope to see more next time. And back to you, Tom.
Thanks very much, Abdur. Those were excellent. Just enjoyed, I enjoyed everything tonight. I don't have any particular announcements. Are there any announcements for anyone? Alistair?
Yes, I do. If you could share screen, I have a couple of minutes of stuff from the National Society.
Go ahead.
Thank you. Okay, so there's been a lot of stuff going on at the national level. As you may have heard, there's been a fair bit of turnover at the national office. One of the reasons that it's been hard to reach people, but we've got now a whole, well, not everyone here is new staff, some of them are. And just a reminder that when you contact them, remember they are people at the other end of the line. And we have a very horizontal structure. We're not like Amazon where you're just going to get some schmo dealing with phone calls. These are amateur astronomers in their other part of their lives. So when you call them, these are the people that you're going to be handling you. There also recently was a move to a new office building, and the Dorner Telescope Museum is now in place. They're still unpacking, and it will be a while. There's some in-reach sessions going on coming up very shortly. Some folks have had trouble with the listserv and the forum, and there's a session coming up later this week, as well as at the start of next month. Please go to the main rasc.ca to find out how to sign up for these. Also coming up, our General Assembly towards the end of June, where lots of good astronomy stuff is happening, along with the Friday night wine and cheese that allows everybody just to walk from one person to another, and you can actually do this virtually. It's a pretty cool thing to do now. Again, apologies from the national office for all those dropped and misdelivered items, but essentially it should be now complete. If you have anything that you ordered that you never got, please phone and leave a message or talk to one of the folks at the other end of the line there. They'll also soon be sending out packages to new members. And there's a lot of programming coming up, including the new observers to visual astronomy. If you want to get going on your telescope, more than what we offer here locally, which I'll get to in a minute, you can sign up and get some help online, a new 10-week course starting up there. For the robotic telescope enthusiasts, anybody connected to especially high school students, please know that there's all sorts of cool data, and they're actually doing exoplanet transits. I mean, hey, 60 years ago, let alone 10 years ago, we weren't doing it. I think 30 years ago, there were no other planets in the entire universe, and now there's thousands and bazillions of them, but we can actually follow them. So it's as a high school project, just amazing. So that's some of the stuff that we're doing there. The robotic telescope itself, just in case you were not aware, was not funded by membership fees, but by donations. There are data packages which you can purchase, but there are also processing competitions where you get free access to some of the big things like the Rosette Nebula and that kind of lovely big red blob, which you're supposed to sharpen up into an amazing picture, so you can do that. There's also, they're moving forward with the science team on that. So there are, you can look at that through the, again, rasc.ca webpage, and there's monthly blog updates. And then also something that I've signed up, for example, is a Stellarium. I've got to level 1 by myself, but I'm stumbling around a bit. And so I've signed up for a training series for level 2 and eventually level 3 to learn how to better use this piece of software for my astronomy planning. And so it's also available to you. You do need to sign up. Don't wait for it, because there is a waiting line, and they put you in queue. It's very much, it's not a sort of a one-to-many, it's a virtual classroom. So they actually keep limits on the number of people that can sit in a session at a time. And of course, there's a lot of public outreach to schools and the elementary side of things. So something to, for the younger ones in there. We have for the observers, especially the deep sky, those who want to see star clusters, galaxies, with their telescopes. There are some webinars available on the national site. And finally, we're getting close to the Lunar Artemis launch later this year. The National Society is doing a fair bit in public outreach, and if you want to join in or share this with Edmonton folk, then please step up and volunteer. And then just as a final reminder, we have local things going on here in a couple of nights for members. We have the Astro Imaging Cafe, hosted by Arnold Rivera. There's myself at the end of the month, Introduction to Stargazing. Things got bumped a week, so it's not quite the 4th Wednesday of the month, it's the 5th Wednesday this month. And then 1 week after that, Jeff Robertson's What's Up in the Sky this month. And a month from now, the Observers Group has a web Zoom chatting session, which hopefully real soon we'll get into face-to-face. So thank you for your attention, and that's it from National.
Thank you, Alistair. While you were showing that, I was thinking about the first issue of Stardust and the hand-drawn comet with the star at the end and the comet at the end and the typing, and what those that put together that would have thought about the graphic presentation that you made today regarding this. But it's still the same object, still the same mission, and still the same good work that's being carried on. So Clayton also has an announcement to make. Clayton?
Thanks, Tom. We're probably going to be starting to receive some outreach requests from schools and different organizations. We already have one from a school out in Fort Saskatchewan where they'd like us to come out to do some stargazing with them. But at this point, even though we have lifted restrictions, some of us are still a little concerned about going out and sharing eyepieces. So I sent out an email a week or so ago asking people if they're still interested who are on my volunteer list, if they would still want to volunteer with us. I've got about a half of them have responded, and so thanks to those who are sticking with us. And if anybody else is interested in getting added to my outreach volunteer list, let me know. I will put your name on the list. And I'm working on a document right now that will I'm going to present at this month's council meeting with respect to how will we move forward doing outreach right now? I know in October we went up to Jasper last year and we were using cameras and monitors to let the public see what was going on, because a lot of us are still a little nervous about sharing eyepieces. So I would say that would be one of the things we will not be doing, and would like to continue using cameras in the short term at least, until we come up with a better way of being able to share eyepieces. I guess people could bring their own and stick them in. I don't think that's going to work too well. But in the meantime, if you're interested in volunteering, just get a hold of me at the outreach or public education director email on the website, and I'll add you to my list. If you want to be taken off the list, same thing, just let me know. Anybody got any questions? No? Okay, that's all I have.
Thank you, Clayton. And it's a great sign of spring that the volunteer coordinator and outreach coordinator is asking for volunteers, don't you think? I think that's a great sign. So this has been literally a historic evening, and I've enjoyed it. Thank you all for coming, and we will see you at the next regular meeting, and I'm looking forward to it. All right, well, good night, everyone.
Thanks,
Thank
Tom.
you.
Good night, everybody.
Thanks, Tom.
Good night.
Take care. Have a good night.
Good
Have a
night.
good night, sweet
Good night.
dreams.
Good night, everyone.
Good night.
Cheers.
Good night.
Good
Good night, all.
Good night.